It's really cool. You can't see it, but it's awesome. All right. I'm going to put these on YouTube so you can see them if you need to review what we're talking about today. This first one is what family of functions? So it's absolute value. Absolute value looks like a V. It looks like a V. So let me draw one of these. And before it's shifted, it goes through the what? The origin. And from there, it normally goes over 1 and up 1, because the absolute value of 1 is 1. The absolute value of 2 is 2. But also the absolute value of negative 1 is 1. Absolute value of negative 2 is, whoa, I went way too high there. And so you get something like this. And that is y equals the absolute value of x, or f of x is the absolute value of x. What transformation has been applied here? Down 3, and before that, it's been, what happens in here? To the left 2. Why did the left 2? Because if you plug in negative 2, it makes that 0. And the vertex of a absolute value is always found at what makes the inside equal 0. So negative 2 makes it 0. Its vertex is over here then. Let me do this dark. And it's the same pattern because there's no stretch or compression applied to it. Oh, wait. Darn it. I'll have to do this. This is y equals absolute value of x plus 2. And now if we take it one more step, there's also a translation down. So from here it goes 1, 2, 3 down. And so here is the final thing. And you don't have to do all these intermittent steps. In fact, I would have just gone from here right to here, but I messed up. But if you want to go, always shift it over first and then to shift it down, you know, and break it up into little discrete steps, you can certainly do that. How many of you got that? Okay. The second one we chose, or I chose it actually. This is f of x equals 1/2 the absolute value of x. So we're still dealing with the same family. But what does a 1/2 do? It makes it wider, but why does it make it wider? The slope will be going up 1 over 2, but you know, when you talk about slope, that only applies to things that are straight. So in general, the reason it's going it's wider is because the pattern in the y has been cut in half. So it used to go over 1 up 1, now it goes over 1 up a half. So the pattern in the y, when there's a half in front, the pattern with respect to the y is cut in half. So normally it does this, but now, and it hasn't been shifted to the left or the right or anything like that. So it's still going through the vertex, or through the origin, I should say. But instead of going up over 1 and up 1, it goes over 1 and up a half. Instead of going over 2 and up 2, what's half of 2? 1. So it's going to, and just like Alicia said, it will have a slope of 1/2. But I don't want you to think that this is a slope. It's only the slope in this case because this is a linear function piecewise. When you look at it in pieces, each piece is linear. But if you have a curve, what you need to remember is this 1/2 in front affects the pattern of the outputs. It cuts the pattern of the y's in half. So what you would normally do in an up-down direction, you cut that pattern in half. And same thing going this way. Questions on that? All right, I'm going to do one more. It is not an absolute value function. Rather, it is a square root function. And this one's messy because it has 2 negatives in it. This is number 43 in your textbook, section 2.3. So f of x equals negative the root of 1 minus x. This thing has 3 transformations happening to it. if you look at the x, the first thing you should notice is what? There's a negative on it. So there's a transformation happening there. Then there's a positive 1 being added to it. So there's a transformation there. And then outside there's another negative. So to keep track of all this, I'm going to first draw our standard graph, which is for a square root, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is, of course, 2, and so there you go, that's our square root function. Now this has some stuff happening to it. The first thing I do is ask myself, what does a negative inside do? Anything inside affects the input, which means it affects it in a left-right way. So a negative on the inside is going to take this thing, which is pointing this way, and make it point that way. Does that make sense? Alright, so the negative inside makes it point the other way. In fact, if you look at the domain of a standard square root function, it's normally, the domain is normally 0 to infinity. But if you solve for the domain on this one, and to solve for the domain, you would say what's inside has to be positive. Right? Isn't that the rule for a square root? You can't take the square root of a negative. So what's inside has to be positive or 0. This is how you find the domain of a root. Well, when you solve this, you move the negative 1 over, you divide by a negative, and the sign flips. And which way is the domain going? It's not going that way. It's starting at 1 and going that way. The domain of this function is negative infinity to 1. Why does it begin at 1? Because that's what makes it 0. Alright, so I'm here and it's going that way. However, we still haven't dealt with this negative outside. So the negative inside kicks it over. The negative outside flips it down. So actually it's going to come out to this nice little function. Instead of going up 1 and the square root of 1 is 1 backwards, we're going to go the square root of 1 is 1 down. The square root of from here 4, 1, 2, 3, 4, 4 backwards, and instead of going 2 up, I'm going to go 2 down. And so this is the graph of f of x equals negative 1 minus x. You can confirm that on your calculator if you want to. Do you think you could do another one with a negative in it now? Some say yes, some say no. Let's try, somebody picked 45. 45 is not that crazy. So let me give you 45. I'll write it up here. I'll pause the video and we'll see how you do. Alright, go for it. Alright, so on this one, it's the same thing as this, right? Same pattern. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, but that pattern's going to be moved. Looking inside here, your first question should be, what makes that 0? Negative 1 makes that 0, so you're going to start, your vertex is going to shift to negative 1. There's no outside garbage happening, so there's no up-down shift. Right? So the transformation is just 1 to the left. And normally, 1 to the left would still go that way. However, because there's a negative on the inside, that negative on the inside affects the x's, the input. So inputs are left-right, so it's a flip to the left. So now it's going to be going that way, but it's the same pattern. You go here. From here, go over 1, the square root of 1 is 1. From here, go over 1, 2, 3, 4. The square root of 4 is 2, 0, and there you go. If you plot points, it's going to take you a lot longer to do that on a test. So that's why you just want to learn the pattern and understand how the pattern is affected by the transformation. Yep, just 3 points on one of these, but any curve that has 2 sides to it, 5 points. 2 points on each side and the vertex. Okay? Let me stop the video.